my name's Tanam Shah and I'm from UNSW. Today I'm working through some of the Math 1011 calculus problems from the section 2.4 on applications of calculus. So here we're given an equation essentially that's modelling the level of pollution in some standard index according to time, as in time measured in hours from midnight, and we're looking at the interval, the closed interval from 0 to 24, so over a workday. We're asked to find what times the levels of pollutant is a minimum and what the values of that pollutant is, what the value of the pollutant is at those times. So the idea is that global minimum or global maximum and minimums on the closed interval, right, we know it's a closed interval, we're talking from 0 to 24, will occur at critical points. What are critical points? There are three types of critical points. We're talking points where the derivative doesn't exist, so let's say non-differentiable points. All right. We're talking endpoints, and we're talking stationary points. Okay. So instead of graphing this, which I could do, and reading my answer off the graph, I'm going to analyse the three types of critical points here, and I'm going to find which point is going to give me the minimum level of pollutant on this closed interval from 0 to 24. Now, there are no non-differentiable points because my equation here is just a cubic, and I can differentiate that cubic. There are no non-differentiable points on the cubic. The endpoints, well, the endpoints are t equals 0 and t equals 24. So at t equals 0, the level of the pollutant is 0 plus 0 plus 0 plus 120. So the level of pollutant is 120. And at t equals 24, we can calculate minus 24 cubed on 6 plus 6 times 24 squared minus 48 times 24 plus 120. And if you do that, you should get 120, which makes sense because 24 hours past midnight and 0 hours past midnight, we would want to be the same thing if this equation was going to model the level of the pollutant. So there are endpoints. They both give us a value of 120. Now, to find our stationary points, we want to solve p dash equals 0. Okay, so let's find our stationary points. When we differentiate this here, we are going to get minus a half t squared plus 12t minus 48. And we want to solve when does this equal 0. I might multiply everything there by minus 2 to make it a bit easier to manage. I can't factorise that, so I might complete the square. So t minus 12 all squared gives me t squared minus 24t plus 144, so minus 144 plus 96 is 0. So t minus 12 all squared is going to give me 48. So t is going to be plus or minus the square root of 48, so that's 4 root 3. So 12 plus minus 4 square root 3. Hopefully that fits in there. So we've got our stationary points here. So t equals 12 minus 4 square root 3. We want to work out what the value of our pollutant is. And at t equals 12 plus 4 square root 3, we want to work out what the value of our pollutant is. So I get my trusty calculator and I work out what this value is when I put in 12 minus 4 root 3, and I get approximately 9.15. And if I put in 12 plus 4 square root 3, I get 230, approximately 230 let's say 85. So we have no non-differentiable points. Our endpoints give us values of 120. We've got two stationary points. One gives us a value of 9.15, which is the lowest among these, and one gives us a value of 230.85. Now the point is that any global maximum or minimum on this closed interval has to be in one of these, So it's either going to be 120 or 9.15 or 230.85, and we can see that this is the minimum value, right? If they were after a maximum value, it would occur at this time there. So let's just write a conclusion up here. So hence, the pollutant is at a minimum at t equals 12 minus 4 root 3 hours past midnight. Let's work out approximately what time that is. That is 5:04 a.m. and the level of pollutant at that time is approximately 9.15 of these PSIs, the units that they gave us. So on a closed interval, if we have a function here, any global maximum or minimums will occur at the critical points. So we just need to examine what those critical points are and find amongst them which is the minimum value or which is the maximum value if we're after that.